Okay, these are some more problems from section 4.6, and this is number 15. Again, this is section 4.6. All right. And the problem says boring a cylinder. The mechanics at Lincoln Automotive are reboring a 6-inch deep cylinder to fit a new piston. The machine they use increases the cylinder's radius 1/1000th of an inch every 3 minutes. How rapidly is the cylinder volume increasing when the bore diameter is 3.8 inches? All right, so this is my cylinder, and the piston's going to be in here. Now, the depth of the cylinder will stay the same. We're just going to make it wider to get a little bit bigger piston in there. So my height is constant. Now, the volume of the cylinder, volume is base area times height. That equals pi r squared times h. Okay, so we're going to need to deal with this because they're asking, the question is, how rapidly is the cylinder volume, so that's the volume of the cylinder, increasing? So we need to take the derivative of this to find the dV/dt. We're going to be looking for dV/dt. So we've got all this information, and basically what they're asking with this information, find dV/dt. So that's what we're looking for. So this is my given information. This is my dr/dt. And the radius, they say, is increasing 1/1000th of an inch every 3 minutes. Well, we would like to have it in inches per minute. So we can just multiply the top and the bottom here by 1,000, or move the decimal point 3 places to the right, and I get 1, and 3 places to the right, I get 3,000. So that's 1/3000th of an inch every minute. Now my diameter is 3.8 inches, so my radius will be half that, 1.9 inches. I'm going to use radius because my volume is pi r squared h. Now since h is constant, that's always going to be 6. I can just put that 6 here, and there's my volume formula. So if I take the derivative to find out what dV/dt is, if I take the derivative of this, I get 12 pi r dr/dt. Okay. And then I just substitute my known values. I know what the radius is. That's 1.9 inches, so that goes here. The 12 pi is constant, so that stays there. And the dr/dt is 1/3000. 12 happens to go to 3,000 exactly 250 times, so I've got 1.9 over 250, or I should say 1.9 pi over 250, but there again I have a decimal over number, so I'd like to get a number over number to simplify the fraction. So I multiply the top and the bottom by 10, so I've got 19 over 2,500 pi. If you divide 2,500 into 19, you get 0.0076 exactly times pi. And then if we multiply this 0.0076 times pi, we have to round it off. We get approximately 0.0239, and that's going to be in volume, so that would be cubic inches per minute, or inches cubed per minute. Okay? So just have to deal with the units, and it's not that difficult. Actually, the problem sounds a lot more difficult than it is. Hope that helps.